Okay, in this section we are actually looking at function notation. This is something very new for you. It's not difficult, but it can be confusing at first. Function notation is basically a name for a function. When we're dealing with more than one function in a problem or two, instead of saying y equals x plus 2, we may give it a name. In this case, we may give it the name of f or g. Okay, F or G. Or we can use H. H is a common name for a function, or R sometimes. But now what we're going to do is instead of saying y equals x plus 2, we're going to give this function the name of f. And we're going to replace it with the y with the function name f of x. Notice there's an x in parentheses. The function name is f. And the way this is read when you see this is f of x. F of x. Okay, what this is saying is that f is a function of x. X is the variable that's being used inside the equation. Okay, and they're saying f is a function of x. This whole thing is a function, so it's not a vertical line when we graph it. It is a function. It passes the test, and we're giving it the name f. So this right here just replaces the y. And that's all function notation is. Basically, we're giving a function a name, and we're getting rid of the y. Okay. The symbol f of x, which replaces y, is read f of x, and I went over that, and represents the value of the function at x. So what that means is if I'm looking at f of 2, this is the value of the function at x equals 2. Notice the x is in parentheses, so the 2 is in parentheses also. We're just going to substitute. X and 2 are equal. So in the function here, x plus 2, I'm going to substitute 2 for x. And then, so f of 2 equals 4. Okay? So basically what we're doing here is just substituting. Let's look at the next page. Here's our function. It is named f. F of x equals negative 3x plus 8. Remember, this just takes the place of y. I'm just writing this up here just, for us to look at, but f of x, f is a function of x, okay? F of x equals negative 3x plus 8. Now we're going to find two things. We're going to find f of x when x equals 5. That's another way of saying find y when x equals 5. Remember, this just takes place of y. So we're going to find this when x equals 5. Again, we're just substituting. They're telling us what to substitute. X equals 5. Well, their only place there's an x is here and here. So f of 5, I'm just substituting for x, equals negative 3 times 5 plus 8. Okay, I'll work this out. I get negative 15 plus 8, so f of 5 equals negative 7. Okay, all I did was substitute and get an answer. Look at this one. This is a different question. I'm going to find x. So I'm not substituting for x, I'm going to find x. But I am going to substitute for something. F of x equals negative 22. Think of that as y equals negative 22. Where does this go when I substitute? Well, instead of going in the parentheses, it's going to take the place of the whole thing. So instead of f of x equals negative 3x plus 8, I substitute negative 22 for f of x, and that equals negative 3x plus 8. Then I solve. So I subtract 8 from both sides. I get negative 30 equals negative 3x. Divide both sides by negative 3. I get x equals positive 10. Okay, so we did two different things. We substituted for x and found f of x. Here we substituted for f of x and found x. Okay, very basic. Now here's a new equation. It's g of x equals 4x minus 5. Okay, so we're going to find this. Find g of x when x is 2. We're going to substitute everywhere there's an x, we put a 2. G of 2 equals 4 times 2 minus 5. Okay, let's work this out. This is not to be worked out. This is just saying what is the function of g at x equals 2. So we evaluate. 4 times 2 is 8 minus 5, that equals 3. So g of 2 equals 3. Okay, let's look at the next one. G of negative 10. We're just substituting. Again, negative 10 took the place of x, So negative 10 is going to take the place of x on the other side in the equation. If we work this out, g of negative 10 equals negative 45. Okay? Let's look at this one. What is x when g of x equals 19? So we're going to find x. Here's the substitution right here. So we've got g of x equals 4x minus 5. So instead of g of x, we're going to replace that with 19. So 19 equals 4x minus 5. I'm sorry, I was about to write something else. Let's go back a couple. 19 equals 4x minus 5. I do not put the 19 in for x because I'm not substituting for x. I'm substituting for g of x, and I'm going to find x. So I add 5 to both sides. I get 24 equals 4x. So divide by 4. I get x equals 6. And we're done. Let's look at what's next. Graphing. Okay, notice that all I'm doing, since I'm changing the y, and I'm putting in its place f of x, I'm not going to change how I graph. I still have a slope. I still have a y-intercept. Okay, so I'm not really changing anything. I'm just going to graph. The y-intercept is 1. Slope is 3. I go up 3. 1, 2, 3, over 2. I'm sorry, over 4. 1, 2, 3, 4. There's my 2 points. And if I had a steady hand, that's probably the best I can do on this tablet. Okay, let's do this next one. Negative 4. 1, 2, 3, 4. Up 2. Over 1. Okay, draw a line through there. That's the second one. Again, I want your lines to fill up the graph, but I can't draw them really straight with this thing, so we're going to stick with that. Next, we're going to graph this. Y-intercept is 3, slope is negative 3 halves, so I'm going to go up 3. There's my first point. 3 halves, going to go negative 3 halves, going to go down 3 and over 2. I've got a point here, and I got something that goes just like this. Okay, but straighter. Let's graph this one. H of x equals negative 1. That's the same thing. Think of it. It's the same thing as y equals negative 1. The slope is not there. X is not there, so the slope must be 0. Put a point on negative 1. I have a horizontal line. That is terrible. Absolutely terrible horizontal line. But you get the picture. Okay, let's go next. Oh my gosh, what is this? Let's clear this page real quick. Okay, I think I actually went backwards. Let's go forward here. There we go. Writing a function. Okay, this is kind of the same thing we did yesterday, only with a little bit of a twist. Now we're given g of x equals g of 0 equals 9, g of 3 equals negative 6. Now remember, when we wrote a function, we need to figure out what m is, and we need to figure out what b is. Okay, slope and the y-intercept. This is very easy to do. It's just like yesterday. Now, what is inside, remember, what is inside the parentheses is always the variable x. This whole thing represents y. And so we can rewrite rewrite these as points. So x is 0, y is 9, x is 3, y is negative 6. Okay? So we have 2 points here. Now all we need is the slope and the y-intercept. Well, the y-intercept is right here where x is 0, y is 9. Okay, now the slope, remember, x1, y1, x2, y2. I've got negative 6 minus 9, that's negative 15, over 3, that's going to be negative 5. Now I'm going to write the equation. I've got the slope, got the y-intercept. I'm just going to call it something different than y. It's going to be g of x equals negative 5x plus 9. Okay, very simple. Let's look at the next one. Let's do 2 points. Remember, what's inside the parentheses is x, what's outside is y. So 0, 1, and 2, 9. I need to know m and b. Well, b is easy, it's 1. Right there it is, it's with x equals 0. 9 minus 1 is x, y2 minus y1 is 9 minus 1, that's 8. Over 2 minus 0, 8 over 2 is 4. I'm sorry, I totally did that wrong. This is 4, this is 1. There we go. We're going to call this f of x, because it is f over here, that's the name of the function, equals 4x plus 1. Okay, this one, what would be the points? Well, negative 6 and 16. 0, and -5. There are the points. Again, inside the parentheses we have x, outside we have y. Use the slope. Here's the y-intercept right here, -5. Find the slope, you've got an equation. Okay, write the points here, 0, -7, 6, 5. Again, find the slope. Here's the y-intercept. Write the equation. Write the points here. I've got -7, 3. I've got 0, 3. Here's the y-intercept. Find the slope. You can write the equation. Again, once you get it here, it's exactly like we did yesterday, except for the fact that I'm going to name it by the name it's been given here. So this one would be g of x, this would be f of x, and this last one would be r of x. Okay, let's look at the next. After a balloon was released, it rose at a rate of about 500 feet per minute to a final altitude of 120,000 feet. Use function notation to write an equation given the altitude of the balloon as a function of time. Okay, so function of time, that is the variable inside the equation. Altitude is y. Okay, altitude is a function of time. Y is a function of x. Altitude is y. Time is x. And so we're going to call this, let's call it, since it's altitude, we can call it a of x. And it's a function of, I'm sorry, it's not a of x. We're going to call t time, even though I don't like to do that. Let's call this a of t equals, well, it goes 500 feet per minute. That is a rate that is multiplied by the variable 500t. Okay, that's our function. I just used function notation. Instead of y equals 500x, we just used a of t and got a little fancy with it. Still wrote the same equation. How long did it take the balloon to reach its final altitude? Well, here's the final altitude. So the final altitude is not time, it's height. This is height, this is time. Okay, so we're replacing height or altitude with the final altitude here, and we find out what time is. Okay, then I would divide both sides by 500. Okay, I'm sorry, that's the division side. We get rid of that. We got 5 into 1200, so it's going to go, let's see, I'm sorry, 5 into 12 two times, remainder 2, 5 into 24 times, 5 into 0, 0. There we go. 240 is our answer. And it's 240 minutes, because we're talking about minutes, I think. Yep, feet per minute, so our answer is minutes. There we go. And that's it for today.